Hey everybody, welcome to Collision, and I'm here with Brent, and he's going to talk today about containers.
Awesome. Thank you, Alejandra. All right, so if you were here yesterday, we talked about how to build your first container. And we went through the build process, we went through optimizing. I gave you a GitHub link to all of that work. You probably saw all of the Docker push to ECR, Docker pull from ECR, all of that's available to you. Today, what I want to talk about is what do you do after that? What's your next step or steps? And then, some decision making around where should I run my containers and how should I run my containers. So that's what this talk is about. We're going to talk about deploying and auto-scaling our containers, and then we're going to look at, a feature or two that might be handy for you to be aware of on our platform. So, basic core concepts. We're going to talk about decision making and the thought process that you should be in when you're thinking about containers. And then we're going to dive into auto-scaling, and we're going to take a look at service discovery. So if yesterday you ran Docker pull, Docker run on an instance, you would have seen that our Hello World app, you could deploy it out onto any instance that can run Docker. So if you have an EC2 instance, remember our app yesterday was written in Node, it doesn't need to even have Node installed on it. And you can Docker run, and you can have your Node app up and running. And that's because Docker allows you to be portable, allows you to take all of the necessary components with you and execute them in whatever environment you happen to have available to you. So that's great, but that was one instance. Imagine if you had to do that across 10 instances, or across 50 instances, or across 100 or 1,000 instances. When I first started using containers, I was at Spotify, and I was helping build Spotify and scale Spotify. We ran in data centers all around the world. We had thousands and thousands of hosts that we would run containers on. How in the world can you expect to do Docker run everywhere that you need it to happen? How do you orchestrate that? So we actually started building an orchestrator. About the same time, AWS started building an orchestrator, and it's called ECS. So orchestration was very early the thing that was designed to solve this problem. I need to be able to very quickly and easily manage and execute Docker commands out onto a fleet of instances. And then if an instance dies, a new one can come up in its place, and I'll still issue it Docker commands. So orchestration should be your next step. Now some people think in terms of, well, I have a config management system that can do some things like that. I have Chef or Puppet or Ansible. I can orchestrate with that. But the problem is those systems are all built around the notion of paying attention to what's happening on a single instance. And we want to stop thinking like that. We don't care about single instances anymore. We want to think in terms of, is our app running, is our app healthy? And as long as that's the case, I don't need to care about if I'm at 10 instances or 50 or 100. I just need to have enough to be able to run my application and have it be as healthy as it needs to be. So, we have a choice at AWS between orchestrators. ECS has been around for years now. It's the one that is massively scalable. It can run as many containers as you would ever want to run. It's region-based, so you can launch ECS and all of your containers into one region and then launch it into a completely independent, different region. You can have global scale using ECS. Our other choice is EKS, the Kubernetes service, the Elastic Container Service for Kubernetes. That service gives you an open source experience. So if you're used to having Kubernetes in your data center, and you want to take all of the tooling and all the workflow that you've already built maybe, or maybe you're on another team and you have a team that has built it and you can borrow all of their work, that's another possibility. Take all of that, move it into and start using it on EKS. So both orchestrators are great. ECS gives you some native integration into other parts of AWS, and that's really what I want to show you today, the time savings that you can get by using integrations. So let's talk for a second about autoscaling. I said we wanted to stop thinking about instances. You know, when you're scaling an application and you have one service per instance, then you know that, like, well, if I'm running low on resources, if I'm not able to serve enough or all of my customers, all of that traffic, then I need to add instances. And if I need twice as many instances or twice as much capacity to serve my customers, then I'll need twice as many instances. That can be expensive, that can be cumbersome, because you'll then probably reach a point where you'll need to scale back down, and you'll have to figure out, how do I knock down, how do I take away instances so I'm no longer paying for them. Instances also take minutes to come up, and depending on how you've orchestrated all of the other changes that have to happen, updates to load balancers, updates to DNS, updates to service discovery, all of that orchestration takes time as well, and it might take effort for you to build all of those connections. Autoscaling is something that, if you're using ECS, we can simply turn on. We can simply, like, almost check a box and you get it. So if we think about what do you need to autoscale? Well, first you need to understand how much traffic can my service handle. And then you need to be able to see how much traffic is my service getting. So those are metrics. You then need to be able to have a place to store those metrics, have a length of time that you can look at the history of how long, what does my traffic pattern look like over the last amount of time, and then you need to be able to make a decision on when am I supposed to scale up. So for us to be able to have auto-scaling, we need to have a metrics service. We need to have a time series database. We need to have an API that we can query and find all of this information, and then we need to have something that can make a decision for us and say, yep, it's time to scale up, or yes, scale back down. So all of that we've actually built for you in ECS and in AWS, and we can have it all work together. So with target tracking autoscaling, you just specify the target. I know my application can do 1,400 operations per second, so I'm going to try and keep it at around 1,000. That way I have a little bit of buffer, and if I go over 1,000, I'm going to scale out. If I go under 900, I'm going to scale back in. So I'm going to target a certain number of operations per second that's near the top of where I know I can handle. Now, how do you build this? So, when you deploy your container, you deploy it using a task definition on ECS. Once you've deployed that, you can actually build a scalable target. So I've highlighted the important points of this command, but this command is register scalable target. And what I'm saying is, scale on the dimension of desired count, and the desired count is ECS demo front end. So in other words, change the count of those containers. The minimum capacity is 3, so I'll never go below 3, but I will go more up to the maximum of 25. So my scalable target is the container count. So this is a really simple way of just registering that as the thing that I want to auto-scale. Then the next thing I want to do is build a policy. What is the policy that I want to use? Put scaling policy, and then I pass it a JSON file, but the JSON file looks like this, and again, the important things are highlighted. Track ops per target. I said 1,000 operations a second. By the way, I chose this. This is actually a real application. You can deploy this yourself if you want to. This is in ecsworkshop.com, and it's the front-end application. I chose this one because it was written in Ruby. I wrote it in Ruby because I wanted something that was kind of inefficient and slow. The other two applications in the workshop are written in Node.js and Crystal. And those are much faster and can handle a whole lot more traffic, and that's actually harder for me to then generate a whole bunch of load and send it. So I kept the Ruby one as the front end. So track ops per target, I know my Ruby application can handle roughly 1,400 operations a second. I tested that, I got to that number using Apache Benchmark. And once I had figured that out, I backed off a little bit, and I said 1,000 is a nice round number. So target value is 1,000. And then I'm getting the metric, you see predefined metric type is ALB request count per target. So I see that I can actually look at the per target metrics, and I want to emphasize per target. So if I'm at 3 minimum capacity, then that means I can handle 3,000 operations per second total before I need to make any decision. But it's still 1,000 per target. As I add targets, as I bring on additional containers, I'm still targeting 1,000 per target. So it's always the per target metric that I care about. And the reason that's important is because when you start to look at something like this is a graph of me sending it a whole bunch of traffic. You see the Apache Bench command that I use to generate traffic. So I just start flooding it with traffic, a ton of connections all at once. This is 9 concurrent connections as fast as I can send them. And then I just keep doing this over and over and over again. I'm sending it thousands of connections per second. As that happens, you see that the per target connection count goes up over 1,000. So we set our target to 1,000, we easily exceed that, and so an alarm goes off, and we say, okay, time to scale out. This is the continuation of the graph. A few minutes later, you see that when we scaled up, it was 1803, 1804, and then as 1804 and 5 and so on, the graph starts to go back down. It's because we keep adding more containers to handle the capacity, so the per target rate goes back down until eventually it's below that threshold line, below the 1,000 line. So that's when we stop scaling out. This is what it looks like in the event log. You can see that ECS demo, let's start 3 down, has started 1 task, and it shows me the new task, and then it registered it in the target group, making it available to take traffic, and then it reaches a steady state a few seconds later. So this is all managed very simply and very easily. I built 1 container, I deployed 1 container, I set a minimum, I set a target, and AWS ECS took care of everything else. The code for this demo, by the way, is here on GitHub, so you can definitely check this out. You can build it and run it yourself, and you can do this and see how easy it is to have auto-scaling for your application. And you can scale out and then scale back in on demand without having to build a metric service, build a log collection service, build any kind of application to make decisions about scaling out and in, all that stuff. So another integration that I think is really cool and oh my gosh, so much of a time saver is service discovery. Does anyone know what service discovery is? Okay, 1 or 2. So basically, service discovery is how microservices figure out how to talk to each other. So if you think about like before microservices, you had a monolith, and the monolith would understand that like this function or this piece of code needs to talk to this other function or this other piece of code, but it's all inside the application, so it's all very simple to call. Well, once you break all of that apart and you start running externally, you have to make network connections to all of these other microservices. So to make a network connection, you have to know where to find the microservice. The easy way to do that is to build service discovery. Service discovery can be handled any number of ways. One way that it used to be done that was probably the most common is to actually write a record into a database and then have that database have an API front end that you could query. So I'm looking for ECS demo Node.js, and you would send that query off, you would get back a response that was a list of all the IP addresses where I could find that service. Well, that ended up sort of getting replaced. The most popular way to do service discovery today is over DNS. So if you think about it, DNS was built for stuff like this. Just send a query, tell me what address I can find something at, and get back a list of addresses that you can find it at. The downside to DNS is you have to have something that registers with a DNS service, and containers come and go very quickly. So you have to have something that registers and deregisters. When the container comes up, register it with service discovery. If the container goes down, take it out of DNS so that you no longer send traffic to that endpoint. And that should happen very, very quickly. So think about, what do I have to build to make that happen? I have to run a DNS service. I have to have a couple of API calls, one for registration and one for deregistration. And then I probably have to have something that monitors my container activity, and every time there's a change, it has to go and reflect that change into DNS, right? Well, we actually said, you know what? That's hard. We can build that for you. So we built something that was an integration between ECS and our DNS service called Route 53 that can actually do all of what I just said for you. This is kind of the architecture of what you would end up using. So you have traffic coming in from the internet, the little cloud, right? It hits your application load balancer, and that's what routes typically to the front end. So you typically have your load balancer exposed externally, and then traffic passes to your front end. But your front end needs to know, how do I find and how do I talk to all of my back-end APIs, all of my back-end resources? That's the perfect case for using service discovery. So the way the front end finds its back ends is using its special DNS name. It'll just talk to that DNS name like it would any other DNS name, open a connection and start talking to it. The way DNS stays up to date, you see outside of all of this workflow is the ECS control plane sends updates to Route 53. So outside of all of this, ECS is updating and keeping up to date Route 53, registering and deregistering containers as they come and go. Now, how do you get to use this? Well, it's super simple. When I bring up my application, I just add in, I need this to be registered into a private namespace. In this case, it's called service. And then enable service discovery. If you were doing this in the console, it would literally be a checkbox. So you don't have to build anything additional. You don't have to run anything additional. You just literally check a box and you get service discovery. So this is what it looks like, the definition for my front end. I'm saying ECS demo front end should have an environment variable telling it how to find ECS demo Node.js. So the variable Node.js URL is located at that HTTP endpoint. And this will just do a simple DNS query, ECS demo Node.js.service, just like it would for any other DNS name. Here's a video. You can see in the upper left-hand corner, let me make sure this is running. The upper left-hand corner, I'm just sitting there doing a constant query of ECS demo. In this case, it's Crystal. But I'm showing you that there's an endpoint in each availability zone, 100 and 101. What I'm going to do in the bottom is I'm going to kill 2 of those 3 tasks. So this command that I'm running now is killing 2 tasks. And you'll see it up at the top in about 10 seconds or so, 2 of those will go away. We'll be left with 101. And it'll come and go, I think, once more. DNS is like, what's the word? It's eventually consistent. So we'll send a query, we'll get the addresses one more time, but then it'll be gone again. After about 30 seconds or so, ECS will see, hey, we're below our minimum of 3. Remember that minimum for autoscaling that I had set? We'll be below the minimum of 3. I need to add 2 more. And so you'll see 2 new addresses that'll pop in probably about 30 seconds. I mean, think about that. Like, if you were doing this with EC2 instances, well, first, you probably wouldn't have this built automatically, and second, you would probably get paged if 2/3 of your infrastructure just evaporated, and you would have to sit there at 3 a.m. and figure out what just happened, what do I need to do to fix it, and then you would be bringing stuff back online, right? I see smiles, I see people that have done that. This happened before the page would have even gone out. We're already recovered, we're already spread all the way across 3 availability zones again, and no need for anyone to be woken up. Traffic never went away. I was able to serve all of my requests the whole time. So that's pretty cool. You get all of that simply by checking a box and deploying your service using service discovery. You can see this demo at ecsworkshop.com, Node.js backend. And in fact, throughout the workshop we use service discovery, so if you just want to run the workshop itself, you'll discover this and a whole lot more. So that's really it for my talk. I kept it short since we were having internet problems. Who has questions? What questions can I answer? There was a question.
Hi, quick question. When you set a target value, are you setting the number of tasks or EC2 instances?
So the question is, am I setting the number of tasks or the number of EC2 instances? What I didn't get into, and I probably should have, I'm actually, what you saw just now were 0 instances. I don't have a single EC2 instance. What I'm using is actually Fargate. Now, everything that I showed you can work using ECS backed by EC2 instances, but the scaling dimension is number of tasks. So one of the cool things about using Fargate, if you don't know what Fargate is, it's a platform that you can use to launch containers onto, and you don't have to worry about instances. There are no instances. You just launch containers. Containers get network attached directly to them, and they can execute code and serve traffic without having any instance to have to worry about. So there's no more rebooting, there's no more kernel patching, there's no more running out of disk space and stuff like that to have to worry about.
So Brent, we also have a question from the Twitch stream chat. Joseph Ireland is asking, do you have a way to simulate traffic instead of consuming it and getting billed for it? I'm just curious to know if there's tools to help verify scalability.
Yeah, I think web application firewall is probably the thing that I would tie into this to handle that. The question is about how do you validate that the traffic you're getting into your service is not just bogus traffic? And you can do that by building rules in a WAF, and you can let the WAF take all of the traffic and filter the bogus stuff away and let pass through all of the good stuff.
So just a follow-up question. If you have ECS deployed on EC2, in order to have auto-scaling of the underlying infrastructure, you have to integrate with CloudWatch and do the traditional auto-scaling. Is that correct?
So the way you would handle that is you would actually watch for resource exhaustion. And I've seen a couple of creative approaches, and I think that this is probably one of the next problems that the ECS team is going to work on solving. But one of the creative approaches that I saw and liked was to have a job that basically looks at all the tasks and their sizing, find the biggest one, and then count how many can I deploy of that biggest task. And that gives you a sense of how much extra capacity do I have. If I don't have enough to deploy even one of that biggest task, then maybe bring more online so that I have a little bit of spare capacity available to be able to scale up more containers. So that was one. I can find the blog post that walks you through the code that'll build all of that for you if you want. But that was one of the coolest examples that I found is you don't have to care about every container. You really just have to care about the biggest container, and can you add more of those? And as long as you can add more of those, you have capacity. You have enough spare capacity. But if you can't add one of those, then you should have a little bit more spare capacity added on, so bring up more instances. And you can have all of that be automated for you.
Do we have to move the public DNS to Route 53 for the service discovery to work?
Can you start the...
Do we have to move the public DNS to Route 53 for the service discoverability to work?
So the DNS service discovery is actually private DNS, not public. And it only works inside the VPC. So those DNS queries stay limited and private inside the VPC, won't work outside the VPC. So hopefully that's a good enough answer. I don't know if you could, even if you wanted to, I don't know if you could make that public. Any other questions? All right, I'll be around for a few more minutes over in the AWS booth. If you'd rather come over and ask me questions there, come find me. Thanks, everyone.